This is part 5 in a series of videos in which I'm attempting to repair and restore an HP9862A plotter. If you've watched the previous videos in this series, then you'll know that this machine's had a fairly rough life. Looks like it's been severely damaged at some point. And I've been repairing various parts of it, mostly the minor cosmetic things. Had a bit of a major issue with the X potentiometer, but I've repaired that, tested it, it's working fine. But one of the major issues I had with this was that the pen lift mechanism wasn't fitted when I got it. So that's this plate on here, and it's responsible for not only covering up the Y slide potentiometer, which is underneath this plate in this housing, but it's also responsible for raising and lowering the pen. So imagine there's a pen normally attached to this, then the plotter moves the pen around to plot wherever it wants, but it needs to be able to raise and lower the pen. So it has to raise it when it doesn't want to draw, or when it's switched off, and then it lowers the pen when it wants to make contact with the paper. But of course the platter's not, it's not perfectly flat, and also you get different thicknesses of paper, and it's got to take up different pens, that sort of thing. So it has to be sprung, it has to have a degree of flexibility in its positioning, so it's kind of spring loaded, and also you need to be able to replace the pens. So because this was missing and I didn't have another machine to compare against, I looked in the manual, but the manual wasn't really much help, although it does have a kind of representative drawings of some of these parts. They're not clear enough to make any new parts from. And because I didn't know how this machine actually worked, I didn't know the geometry of how the pen lift worked. It actually worked the reverse of what I thought it did. I started from scratch with what I did have. I just had this plate. I realised it pivoted on 2 points, one at each end, and then I had to figure the rest out. I unfortunately didn't have a pen holder either, so I wasn't quite sure which way this tilted to raise or lower the pen. Initially I thought it lowered the pen by tilting this way, because it seemed to make most sense, but as it turns out it does the reverse. It tilts flat to lower the pen, which might seem a bit counterintuitive, but I'll explain what I've found. Now if you do have one of these machines and I've got this totally wrong, then please let me know, but I don't have any decent photographs or drawings to go on, so I've just been trying to figure this out from scratch. So I thought I'd post this video in the hope it might help somebody that is restoring an old machine like this and comes across a similar sort of issue. This is the sort of thing you do get a lot when you're restoring old machines. Parts are missing, and there's quite often no drawings for them, so sometimes you just have to redesign them. So what I've got now is what I think is a working representation. Now these aren't the parts I'll be using in the final repair, these are just really to get the geometry of the various parts correct. So I started by looking at the schematic for the solenoid driver, so we'll have a quick look at that and explain why I started off with the electronics rather than the mechanics. So this is the schematic for the solenoid that controls the pen lift. That's this solenoid here. It's quite a small solenoid, but it's quite a clever circuit that drives it, and as I say, I started here for a particular reason. And whenever you've got a solenoid controlling something in a machine like this, it's always quite useful to look at the drive circuit for it, and it will give you some clues as to what it's trying to drive mechanically. Now in this case it's quite clear that this circuit is, so it's quite clever, it provides quite a high initial current to the solenoid for a short period of time, and then it relaxes it. Doesn't go off completely, but it relaxes it to quite a large degree, but the initial impetus to the solenoid is very high. So in other words, we've learnt two things from this circuit. Firstly, the solenoid is energized when the pen is lowered, which is what we'd expect anyway. It's unlikely the solenoid would have to be de-energized to lower the pen for two reasons. Firstly, because it would probably burn out eventually if it's left like that for too long, but also because when the machine's turned off, if the pen's lowered, it's going to cause the pen to dry up very quickly. So almost certainly the solenoid should be energized when it's lowering the pen. That's what initially confused me, because the way this is laid out, it didn't make a lot of sense, because it would do the reverse of what I was expecting. So I started with the schematic, realized it was going to be providing a very high initial impulse, and that means that it's likely to be trying to overcome quite a large spring force or mass. So I then started drawing the various parts of the geometry. So I did some very rough Dave CAD sketches, did quite a few of these, trying to figure out what the geometry was. Then when I figured out or realised that it worked the reverse way to what I originally expected, that is this plate goes down this way to lower the pen, and then it made a lot more sense. But then I had to figure out the geometry for the various parts that I've never seen, and effectively had to redesign it. As I say, there are some sketches of the parts to a certain extent in the manual, but they are nowhere near clear enough to allow me to make parts for. And I only had some fairly vague photographs of the pen holder. So I started with the pen holder, and also looked at the witness marks on the machine and realised there's a kind of a slide mark up and down here, but it's not going to be running on there when the pen is down, because that wouldn't allow the pen to take up any differences in the platter. So this must be the raised position. So in this position where it is now, the pen is raised, and also it has to be sprung, so there must be a way for this to go down. There's a spring down here as well that is pushing the pen down. So if you imagine the tip of this is the pen, then as this goes down, you can see that the pen is lowered. As I said, this is just a representation to give me the geometry that I need to design a final part for. But rather than making up a full part, I wanted to see exactly what was going on. This is quite a good way of doing that, and it also allows me to pick out the important contact points. So here we have 4. There's one here, one here, one here, and there's one where the spring is, and then we just need to figure out how high the pen should be, but we can do that easily later on. Once this is done, and also I picked this point to match the marks on the machine, and that will give me in theory the right geometry. I also had to straighten this out, it was fairly badly bent up. Once I'd done that, then I had to figure out what was meant to be going on at the back here. So I'll take this out and show you what I was doing, but before I do that, I'll just show you it working. So I'll provide an impulse to the solenoid. This is not in the machine, I've just got it hooked up to the bench supply. If I turn the supply on, you'll see it will lower the pen, and turn it off, pen is raised. So you can see that works quite well, considering this is just a mock-up of the parts. So I'll move the camera closer before I take this out, and you can kind of see how it fits together. Okay, so what we have is there's a spring under here that is responsible for keeping this plate raised. So when I push this down, there's a spring on the pen holder that's trying to push this down, and there's the spring under here now that is trying to keep it raised. So they work against each other, and one of the things I had to figure out was how strong this spring had to be. I'll take it out in a minute so you can have a look at it. And then there's a carrier that holds this transfer lever, and what this does is when the solenoid plunger is raised, if I turn the solenoid back on, you can see that it pushes the far end of this arm. That goes through this point, and there are 2 pivot points on here. Again, I'll take this out in a minute so you can see it. And then on the other side of the pivot fulcrum you have this arm, and this is what actually pushes the plate down to lower the pen. So in other words, when the solenoid plunger is raised, it causes this to be lowered. Now, as far as I know, this is the correct geometry. As I say, if you've got one of these and this is wrong, then please let me know. But of course I also needed to make it so it could be taken out. So I'll just move the camera back, we'll take this out, and I'll show you what I've come up with in here. And in the next video, if this is correct, then I'll make these into more permanent parts. But I'll just back the camera up and then you can see how this all comes apart. Okay, so this rear support, there's a big pin that runs down one side of this plate, and there's a support at the back, but it's sprung, and there's a support at the front that it seems to be fixed. So let's move the camera down so you can see the front support. So this support here is fixed, but this entire plate can move back and forth, and it's kind of sprung with the rear support, which is kind of a springy metal plate that I'm assuming is there to allow this to be taken out. So let's move the camera back up. Oh, before I do that, the pen holder itself pivots, so you can kind of tip it out of the way, and I think these actually lift out, and then this spring down here is the one that keeps this pushed down. I'll move the camera back so we can now take this plate out. Okay, so to get this out, and I think this is how it works on the original machine, you just push this back, the front will disengage, so this front end then disengages, and then the entire part can be taken out. So it's hooked on behind a plate with the spring, and then what we have is two parts. We've got this part, and then the two parts that I've made that I need to turn into final versions are a spring. So I made this with just some spring wire, and then try to figure out what shape it should be, and just give you a closer look at that. So it's just a coil spring with a hook on each end, but just needed to figure out the length and what it hooked on to. I don't know if I've got it right or not, but it seems to work. And then the other part is going to be a single metal plate part. I just made it out of a few parts that were easy to solder together, and this is just a pivot plate that transfers motion from the solenoid through to the actual cover plate. So that's all that's in there. Now, as far as I know, this is the geometry is correct, and I just need to turn these parts into final versions so that it will work correctly. As I say, if you have one of these and it's completely different from this, then please let me know. But as far as I can tell, this seems to work, so this is what I'll use for now.